if an organism, even a slow one like a human, was allowed to reproduce as much as they wanted, well, we would all display exponential growth. So remember, that's called a J curve. And we tend to see species that do this, that produce in large numbers very quickly. We're going to define them as R-selected or R-strategists. I've given you some examples of R-selected species. Bacteria, they reproduce very quickly. Those are termites in the middle picture. Oh, little dandelion seeds. You ever blow those around when you were a kid? So fun, right? Okay, so R-selected species almost always go through exponential growth. That they don't really care for their offspring, right? They have a baby and then it's on its own. They also, I don't know if they consciously realize this, but they know as a species, a lot of them aren't going to reach maturity. A lot won't make it. And that's why they have so many offspring, because only a few actually make it all the way through. They themselves mature almost immediately. They can reproduce very quickly after they themselves have been born. So those are some of the general trends we see with R-selected. Now, why is it called R-selected in lowercase r? Well, we learned about growth rates. And in our rule of 70, R is the growth rate, is a percentage. So that's where this comes from, lowercase r, the growth rate. And R-selected have very high growth rates. Now, unfortunately, we don't live in an unlimited resource environment. And so eventually these things reproduce so much that they blow past what is called the carrying capacity. That is the limit of the population that can be supported due to available resources, competition, and so on. So what happens if an organism blows past their carrying capacity, especially this fast? That's called an overshoot. And what they'll see afterward is a crash. And that crash is called a die-off. Sometimes it's also referred to as a die-back. Now, the crash can lead to extinction. They could crash completely. It could lead to a lowering of the carrying capacity. So the population could plummet and then come back to a much lower result. For R-selected, they tend to be very erratic, and they tend to shoot way over and a whole bunch die, and then they shoot over again. This is called oscillation. And so R-selected species are more likely to oscillate erratically. Now we contrast that with K-selected. If you saw in that previous diagram, capital K was the carrying capacity. The capital K comes from a German word that means the capacity. So R is fast reproduction and K is more leveled out. We could tie this all the way back to feedback loops. R is more positive feedback, exponential growth, runaway train, and K is negative feedback, populations like predator-prey that balance themselves out. We reach an equilibrium with negative feedback. So the carrying capacity is that leveling off that occurs. Notice the first stage of what we call logistic growth. Logistic growth, the first stage is exponential, and then it slows down and then it plateaus. If we call R-selected a J curve, what should we call this one? It's an S curve, good. These are really just the opposite of R-selected, right? They have fewer offspring per litter. They do care for their young, usually, sometimes for years. You guys, 18 years old before we get to kick you out of the house. Most of the members of the species do reach maturity. They make it to what we call life expectancy. And they take longer to mature. So they cannot reproduce themselves until many reproduction cycles after they've been born. Let's look at logistic growth with a couple of quick sample problems. What is the growth rate of the population? That's this line. In the graph at time 90. What is the growth rate of the population right here? It is 0. Now, usually it's somebody who tries to say, oh, it's 100. It's stopped growing. We're looking at the slope of the line, right? That's how we get the growth rate from a graph. So because it's leveled, that means 0 growth. B, did the population in the graph experience overshoot? No. How can you tell? It leveled off, nice and predictable. Okay. Now, obviously, we're looking at perfect ideal conditions, and that is rarely the case in real life. Please understand that R versus K is a spectrum. Organisms do not have to be one or the other. The only thing I'd like to add that's not really on here, and it kind of goes against this line right here, weak competitors, strong competitors. The exception to that rule right there is invasive species. Most invasive species are R-selected. Their sheer numbers outrank any weakness in competition. So you can see the R-selected species is the one wildly oscillating up and down, out of control, dependent on so many factors as to whether it thrives or not. A lot of luck involved with R-selected strategists. K-selected is a much more balanced approach. And as you can see, they go above and below the carrying capacity, just not as dramatically. J-curve, S-curve, exponential, logistic, those are referring to growth. Those are growth curves. There is a second type of curve that College Board will absolutely ask you about, and it is not a growth curve. We're not looking at how a population grows. Instead, we're looking at how a population survives. So it is called a survivorship curve. The number of survivors versus how long they live. Now, really, this is R and K. This is the spectrum, because humans are K-selected, elephants are K-selected. What this means is that most of them live to expected old age before they die. And then they die quickly. Most organisms live to their life expectancy and then die off. Most of your top predators, your larger mammals. Now, I'm going to jump to type 3, because type 3 is R-selected. And once again, these are organisms that their strategy is just have a whole bunch of offspring, throw a ton of seeds out there and hope one of them grows. Most of them don't make it. They die off very, very young. And only 1 or 2 make it all the way to full maturity. Exponential decay is a type 3 survivorship curve. Type 2 is the spectrum, the fact that not everything is R versus K. And some animals, their existence is absolutely due to luck. Some are going to make it and some aren't, and it's kind of random. I think of a bird's nest with 5 eggs. A snake crawls up there and eats one of the eggs. Well, they didn't make it. 4 of them hatch. 1 of them falls out of the nest and dies. They didn't make it. 3 of them are able to fly out of the nest, but a hawk picks off one of the babies. They didn't make it. The other 2 are just fine. They make it to full adults. Okay? 2 out of 5. It's luck. An individual's chance of dying is independent of its age. 50-50.